Let's talk a little bit about the nomenclature of substituted benzenes. And we'll start with monosubstituted benzenes. And this is going to be pretty straightforward. So for instance, you're going to state the name of the substituent, whatever the group is that's attached to the benzene ring, and then you'll follow that with the word benzene. So let's look at a few examples. Here we have an ethyl group on a benzene ring, so I would just call this ethylbenzene. Pretty easy, right? A nitro group on the benzene ring, I will call this nitrobenzene. Next I have chlorobenzene and bromobenzene. Have a look at these four. Think about it for a minute, and then I'll tell you what they're called. We have aminobenzene, hydroxybenzene, methylbenzene, and methoxybenzene. Now, at this point, you might be a little bit confused because I know that you've seen this molecule before, and I didn't call it hydroxybenzene. You may remember that I called this phenol. Well, it turns out that there are also some common or trivial names that we use for substituted benzenes. The examples that I showed you in the previous slide can also be called aniline, phenol, toluene, and anisole. And these are common names that just have to be memorized. The next set are benzonitrile, benzoic acid, and this one actually kind of makes some sense because you have a benzene ring attached to a carboxylic acid. Benzaldehyde, this one makes sense too because you have a benzene ring attached to an aldehyde group. And then we have styrene, which doesn't make much sense at all. But you have seen this before when we talked about polymerization. Polymerization of styrene gives you polystyrene. These names have to be memorized because most of the time they don't make any sense. But you don't have to know all of them. I'm only going to require you to know these 5. Let's look at some di-substituted benzenes now. And these are named in a similar way to the nomenclature of cyclic alkanes. So I would call this compound 1,2-dichlorobenzene. So I have to use my numbers as my locants to tell you the relative positions of the two substituents. This one would be 1,3-dichlorobenzene. And remember, I'm going to number in such a way that I have the smallest locants. So one of my chloro groups would have to be 1. And then in this example, I would number in the counterclockwise direction so that I would have 1 and 3, rather than in the clockwise direction, which would give me 1 and 5. And finally, we have 1,4-dichlorobenzene. Now, when you have di-substituted benzenes, there's another way that we use to indicate the relative positions of those substituents. We use the prefixes ortho, meta, and para. The carbons that are adjacent to the carbon that has the substituent I call the ortho positions, or the ortho carbons. The next 2 carbons are the metacarbons, or these are the meta positions. And finally, directly across from the substituent would be the para position. So this 1,2-dichlorobenzene I could also call ortho-dichlorobenzene. And you'll usually see that abbreviated as O-dichlorobenzene, but we still say ortho-dichlorobenzene. 1,3 could be called meta-dichlorobenzene, and 1,4 would be called para-dichlorobenzene. In the last examples that we saw, the substituents were identical, but sometimes your substituents are different, and when they are different, just like we did before when we were naming cycloalkanes, you're going to put those substituents in alphabetical order. Think about this compound for a minute. What would you call this? Well, we've got a chloro group, and we have a sec-butyl. Remember that we're going to alphabetize them, and when we alphabetize, we never alphabetize the sec. So we're going to alphabetize according to the butyl group. So this could be called 1-sec-butyl 4-chlorobenzene, or it could be called para-sec-butyl chlorobenzene. Here I have an ethyl group and a fluoro group. So this would be 1-ethyl, 2-fluorobenzene, or orthoethyl fluorobenzene. Here I have a fluoro and a nitro. Fluorine is going to be first. So this is 1-fluoro-3-nitrobenzene. Or I could call this metafluoro-nitrobenzene. Whenever there is a common name that I've asked you to learn, you should use that common name. So for instance, if I look at this molecule, I have a carboxylate group, or a carboxylic acid, and a sec-butyl group. Well, if I look at just this part of the molecule, that's benzoic acid. So I'm going to name this as if it were a substituted benzoic acid. So this is going to be 4-sec-butyl benzoic acid, or para-sec-butyl benzoic acid. If I look at this molecule, I've got a hydroxyl group and an ethyl group. Well, a benzene with a hydroxyl group does have a common name. Remember, we called that phenol. So I would name this as a substituted phenol. So this molecule would be 2-ethylphenol, or orthoethyl phenol. Finally, I have a nitro and a methyl group on my benzene ring. Remember that benzene with a methyl group had a common name, and that common name is toluene. So I would name this as a nitro-substituted toluene. My nitro group is in the 3 position, or in the meta position, so this compound is meta-nitrotoluene. Even some di-substituted benzenes have common names. So 2 methyl groups on a benzene ring is a xylene, and they can be oriented 1-2, so that would be orthoxylene, 1-3 would be metaxylene, and 1-4 would be paraxylene. And yes, you have to memorize the xylenes as well. So why don't you try to name these molecules? Go ahead and pause the video, and I'll wait, and we'll see how you did. Okay, let's see what you got. Here we have 3-ethyl benzaldehyde. Remember that this part of the molecule is benzaldehyde. I have an ethyl group at the 3 position. I could also call that the meta position. So this could be meta-ethyl benzaldehyde as well. Here we have 2-nitrobenzoic acid. So this part of the molecule is benzoic acid. I've got a nitro group at the ortho position. This compound does not have a common name. So a benzene with a bromine on it, or a benzene with an isopropyl on it, does not have a common name. So you're going to name both substituents followed by the name benzene. And you're going to put those substituents in alphabetical order. So it's 1-bromo, 3-isopropyl benzene. And finally, we have 4-amino benzoic acid, or para-amino benzoic acid. This is better known as PABA. This is what you'll often find in sunscreens. When the benzene ring is a substituent, we have special names for that, and I think I've told you this before, but we haven't actually used this. So when the benzene ring is attached directly to a parent chain or another group that makes up the main part of the molecule, we call it phenyl. When we have a benzene ring and a carbon attached directly to another group, we call that benzyl. And we've talked about the benzylic carbon before. That would be this carbon right here. So think about these compounds and how you might name them. Go ahead and pause the video and we'll see how you did. So our first one is phenyl cyclooctane. So the 8-membered ring, remember, is cyclooctane. I treat my benzene ring like a substituent, so I call it phenyl. The next one's a little trickier. This one is phenyl acetic acid. This 2-carbon acid right here is acetic acid. My substituent is a aromatic ring, is a benzene ring, so I call it 2-phenyl acetic acid. And finally, we have benzyl chloride.